How large can stars in the universe be? The Sun is just a speck of dust compared to them. This is the core of our solar system. The Sun, a yellow dwarf star. It's actually larger than 80% of stars in the Milky Way. But in the universe, it's just a small fry. This is Sirius, the brightest star in the night sky. As a blue giant, it has greater mass and volume than the Sun. This is Elnathan Taurus. Located in the direction of the constellation Taurus, the Trisolaran Second Fleet was destroyed in this region. This is Pollux, an orange giant star that could contain about 77 suns. This is Arcturus, the brightest star in the constellation Botes. It could contain over 3,000 suns. This is Sagittarius A in the galactic center, a black hole with a mass 4.4 million times that of the Sun. The entire Milky Way, hundreds of billions of stars orbit around it. This is Aldebaran. It could contain over 9,000 suns, but has only 1.15 times the Sun's mass. This means it's a bloated red supergiant. Our Sun, in 5 billion years, will become just like it. This is Rigel. As a blue supergiant, it has a lifespan of only millions of years. When that time comes, it will undergo a violent supernova explosion. This is the Pistol star with brightness equal to 1.9 million suns. The energy it releases in 6 seconds exceeds what the Sun releases in a year. However, this also means its internal nuclear fusion. Fuel burns extremely fast. It will burn out in tens of thousands of years at most. This is Antares, also a red supergiant. It could contain 700 million suns. This is the famous Wee Scuti. In Scutum, before 2012, it was the stellar king of the observable universe, capable of containing 5 billion suns. But now it has been surpassed by Stephenson 2-18, which could contain 11 billion suns. If we swapped its position with the Sun, all planets within Uranus's orbit would be engulfed by it. In comparison, even when our Sun becomes a red giant, it could only engulf planets within Mars's orbit. There's still a huge gap compared to Stephenson 2-18. However, despite Stephenson 2-18's enormous volume, its mass is only 18 times that of the Sun. Its surface temperature is only 3,200,000. Astronomers discovered it solely because of its enormous size, giving it a brightness 440,000 times that of the Sun, making it a red hypergiant. Otherwise, such a star wouldn't receive special attention from astronomers. According to stellar evolution models, Stephenson 2-18 will gradually disperse into a planetary nebula within hundreds of thousands of years, leaving behind at the nebula's center either a white dwarf or neutron star. It would look just like the current Cat's Eye Nebula. Since its mass is only 18 times that of the Sun, its core region's mass will be even smaller. So in its final stage, its core won't be massive enough to collapse into a black hole. It will only become a white dwarf or neutron star. Our Sun, in 5 billion years, will undergo a similar process, first becoming a red giant, then a planetary nebula, finally leaving a white dwarf at the nebula's center. Before that, during the red giant phase, both the Moon and Earth will orbit within the Sun's interior, reducing their orbital speed, and eventually plunging into the Sun's endless inferno. While theoretically, after prolonged heat dissipation, a white dwarf would cool down into a non-luminous but gravitationally detectable black dwarf. Today, 13.8 billion years after the Big Bang, astronomers believe there hasn't been enough time for white dwarfs to cool into black dwarfs. Therefore, black dwarfs remain a theoretically existing celestial body.